design for manufacturing, because a lot of customers do come to us and they've got their beta prototypes and they're really ready to talk about manufacturing. They might not be ready to place a manufacturing order, but they've got a dozen prototypes or something and they've worked on it and they're working pretty well. And now they're thinking, okay, how are we going to get 100 of these built? And they've already covered the performance of the instrument that they're building. They've got the performance the way they've got, the way they like it. They may even have circuit boards laid out the way they want it, and software written. And the next steps are really build 100 of them, and that's harder if you haven't done the tolerance studies and you haven't looked at the manufacturing methods that are available based upon the quantities that you want and the amount of investment that you might want to make in tooling. Um, we have a customer now that wants to do a little bit of an investment in tooling on some parts, not so much on others, but they're all very complicated parts. So it's kind of a little dance between tool the expensive part so that you can make it at a reasonable cost, but some of the other parts they'll just they'll pay the cost for machining them
Right.
in the
And
short term.
designing, yeah, and designing for manufacturing, when you've got a prototype, you might to to continue on the analogy of one part, right? Call it a cover. When you've prototyped it, maybe it's 3D printed, or I don't know, maybe it's machined or something like that. But when you go into manufacturing, decisions need to be made from a cost benefit analysis, or even just an efficiency standpoint, as to what the quantities you're anticipating you're going to build are, and that number will lend itself to the type of manufacturing process to make that part is. So we routinely do this with our customers. Again, to follow the kind of cover analogy, you know, if they've got a 3D printed cover for their prototypes, maybe they had 5 of them made because 3D printing is cheap and fast, and it allows you to put something in your hands, see it, feel it, and decide this is what you want to go with. When you get into manufacturing, you need to start thinking about how many are we going to build per year? How many do we anticipate building per year? Is this a tens a year, hundreds a year, thousands a year kind of thing? Because depending on that quantity, like John said, there's certain investments in tooling that you can make. And if you're in the tens to maybe hundreds a year, a good consideration for like a plastic cover would be what they call a cast urethane process. It's got tooling is required, but it's a very relatively low cost tooling. And it allows a certain amount of freedom to change the part quickly if you need to. So, you've got an investment in tooling, but it's not that much of an investment. You're talking thousands of dollars as opposed to tens of thousands. You have the freedom to change the part, but it's only good for a couple of hundred pieces on an annual basis. So they're a little bit more fragile. They're a little bit more cumbersome, but you get that freedom in that you don't have to pay as much in tooling. There's not as much upfront investment. Whereas, if a customer is going to be building thousands of something a year, you can very much more easily justify a very expensive tool, 20, 30, 50, $80,000 in this full-fledged steel tool for injection molded parts. Because if you're building thousands over 1 year, you can amortize the cost of that tooling right in, and you don't see it as much. So it's a decision needs to kind of be made up front as to what the anticipated quantities of the product is going to be annually to justify the proper path for how to make some of the parts. And that's all designed for manufacturing.
And the big trick with that is even if you have confidence that your product is going to start selling 500 or 1,000 pieces per year, you still aren't sure if it's that particular product, or after 6 or 8 months, you realize that you're going to have to add a feature and that might scrap your tooling. So it's harder than just saying, well, the quantities are going to be such and such. And you also have to look at how confident are you in the particular design that you're looking at today, and we are you willing to spend the tooling on that? And a lot of it comes down to doing a risk analysis on the engineering. We're very confident about this certain part of the product. It's reasonable to spend more tooling on it. There's some other part of the product where we can see that we really want to make some improvements over the next year. Maybe that's not the right place to spend the tooling money.
And it kind of depends too on how your business model is set up. Startups tend not to have a whole bunch of capital to invest in hard tooling. They need to sell a few units to get a little bit of money so that they can invest it back in and kind of build like that. Whereas bigger companies, they get huge budgets to develop the product, inclusive of very high tooling costs. So that kind of factors in as well, depending on what type of company it is at that time.
Yeah, I kind of thought that design for manufacturing was it's about the product, and it's about the cost and quality of the product, and you want the cost to be lower, you want the quality to be higher, and the right kind of tooling, the right kind of manufacturing methods will give you those.